Hi, good day everyone. This video is presented to you by Sydney Maths. Today we have a question on a three-dimensional object, also known as a rectangular prism. So what we have in front of us is a rectangular prism, and this particular three-dimensional object is also called as a cuboid in layman terms. In this cuboid, there are many different segments, but we are interested in finding the length of segment BE and BH. So that is the question. This question is from Year 10 Mathematics, application of measurements for three-dimensional objects. To start working on this question, the first thing that we have to look at is what are the various surfaces in this object. So there is a surface here, which is the bottom surface, which is also called as surface A, B, F, E. So that's the surface here. There is another surface in this figure which is cutting the three-dimensional object right in the middle, and that surface is this particular surface, which is surface B, E, H. So surface BEH is such that it is cutting the three-dimensional object right in the middle in such a way that segment BH is the diagonal of the object. So we have to first visualize the surfaces of interest in 2 dimensions instead of 3 dimensions. So the first surface of interest is surface A, B, F, E, as this particular surface contains the segment BE, which is one of the segments that we have to find out the length of today. So if you look at this particular object either from here, which is down below, or you look at it from the top, either way, if you try to visualize this object from those 2 angles, this particular surface ABFE becomes a rectangle. Because this is a rectangular prism, all the surfaces are rectangles, that is the outside surfaces, they are all rectangles. So this rectangle here is ABFE, and the segment BE is the segment that is the diagonal of this rectangle. And because this is a rectangle, we know that angle A is equal to 90 degrees. So now we have a right angle triangle, which is triangle A, B, E. And based on what is given to us in the figure, the length of AB is equal to 8. The length of BF, which is over here, is equal to 2. And because this is a rectangle, the length of AE also is equal to 2. Now we can apply Pythagoras theorem to calculate the length of BE, which is the hypotenuse. So Pythagoras theorem says that BE square, which is the hypotenuse square, is equal to the sum of the squares of the two other sides. So it is equal to AB square plus AE square. Now AB square is 8 square, which is 64. So AB square is 64 plus AE, which is of length 2 square, becomes 4. So if you simplify this, BE becomes the square root of 64 plus 4, which is 68, which if you calculate using your calculator is 8.24. So that is your first answer. So we found out the length of BE by first visualizing the surface, looking at the triangle that's formed, which is a right angle triangle, and then applying the Pythagoras theorem. Let's now try to find the length of segment BH. So the next part of the question is to find the length of segment BH. For that, we will again visualize the object in such a way that the human eye, now this is my attempt to draw the human eye, so pardon me if it doesn't resemble the eye very much. So when the human eye is looking at this surface, which is surface BHE, this particular surface, in such a way that it is perpendicular to the surface, again, this surface will look like a right angle triangle. So this particular surface BHE will look like a right angle triangle. Let me draw that. Where the right angle is angle E and B and H are the other 2 points on the triangle. So let's apply Pythagoras theorem again to find out the length of BH. So we'll say BH square, which is Pythagoras theorem, is equal to BE square plus EH square. Now, as we can see that EH is the same as GF, because the object is a rectangular prism, GF and EH are the same. So EH becomes 9 square. So EH square becomes 9 square, which is 81. And BE square is something that we've calculated in the previous calculation, which was 8.24 or square root of 68. So BE is equal to the square root of 68 as calculated previously. So BE square will be square root of 68 square, which is equal to 68. And hence we can substitute that here. So the total becomes 149. So BH square is equal to 149. And hence BH is equal to the square root of 149, which if you calculate using your calculator becomes 12.2. 12.2. So that's the answer for BH, and we know that BE was equal to 8.24 as calculated previously. So that's how you typically solve for this type of a problem. the main things to remember are that you have to visualize the object from the right perspective. So I'll write that down. Visualize the object from the right perspective. From the right perspective to be able to understand what the two-dimensional figure is. So the idea is you visualize the object from the right perspective to understand what the two-dimensional surface looks like, and then you apply Pythagoras theorem to calculate the required segments. So that's it from me from today. I hope you liked this video. Please don't forget to like, share, and subscribe to my channel. Thanks for watching.